this data science course, we would be looking into Introduction to Machine Learning under the following units. What is machine learning? Supervised versus unsupervised learning and common machine learning algorithms such as linear regression, decision tree, and so on. What is machine learning? Machine learning is a prominent and powerful subfield of artificial intelligence. Its core ideas revolves around creating systems that can learn from and make decisions based on data, rather than being explicitly programmed for every possible scenario. Coined by AI pioneer Samuel Arthur in the 1950s, machine learning gives computers the ability to learn and improve their performance on a specific task automatically through experience, typically by being exposed to large amount of data. Component of machine learning. Conceptually, the machine learning process often involves several key components, such as data input. Machine learning algorithms start with data. This could be structured like numbers in a spreadsheet or unstructured like text, image, or sound. This data is used for training. Secondly, learning and training. The algorithm processes the data training, searching for patterns, relationships, or underlying structures. It adjusts its internal parameters based on this data. Thirdly, predictions or classifications. Based on the patterns learned during training, the model makes predictions about new unseen data or classifies it into categories. Number 4, evaluation. The model's predictions are often evaluated against known outcomes, if available, using an error function to measure accuracy. Number 5, optimization. The algorithm iteratively adjusts its parameters to minimize errors and improve its performance until a desired level of accuracy is reached. The ultimate goal of machine learning is typically to automate complex tasks, make accurate predictions about future events, or uncover hidden insights within data that might be difficult for humans to discern. What distinguishes machine learning from traditional programming is its ability to learn from examples. Instead of programmers writing explicit rules for every situation, like a detailed recipe, machine learning algorithms learn the rules themselves by analyzing data. This makes machine learning particularly effective for problems like image recognition, natural language processing, or recommendation system, where defining explicit rule would be incredibly complex or impossible. Supervised versus unsupervised learning. Machine learning methods are broadly categorized based on how they learn from data. The two primary categories are supervised learning and unsupervised learning, distinguished mainly by the type of data used during training. Supervised learning. In supervised learning, the algorithm is trained on a dataset where each input example is paired with a corresponding correct output or label. The algorithm learns to map input to output by finding patterns in the labeled training data. The goal is to train a model that can accurately predict the output label for new unseen input data. Analogy. This is akin to learning with a teacher or supervisor who provides the correct answers for examples study. Common task. Classification, predicting or discrete category or class label. Example include classifying emails as spam or not spam, identifying handwritten digits or diagnosing disease based on symptoms. Regression, predicting a continuous numerical value. Example include predicting house prices based on features like size and location, forecasting sale figures, or estimating a person's length of stay in a hospital. Algorithm. Common supervised learning algorithms include linear regression, logistics regression, decision trees, support vectors machine, and random forest. Unsupervised learning. In unsupervised learning, the algorithm is given input data with any corresponding output labels. The algorithm task is to explore the data and find hidden patterns, structures, or relationships within its own without explicit guidance. Analogy. This is like learning by observation, identifying similarities and differences in the data without being told what category or outcome exist beforehand. Common task, clustering, grouping similar points together based on their features. Example include segmenting customers into different groups based on purchasing behavior, grouping similar documents, or identifying communities in social networks. Associating rule learning, discovering rules that describe relationship between items in large data sets. A classic example is market basket analysis, finding items frequently purchased together. For example, customers who bought diapers also often bought beer. Dimensionality reduction, reducing the number of variables features in the dataset while preserving important information. This can simply simplify analysis, improve model performance, and visualization. Algorithm. Common unsupervised learning algorithms include K-means, clustering, hierarchical clustering, principal component analysis, PCA, and a priori algorithm. Common machine learning algorithms, conceptual introduction. While the field of machine learning encompasses a vast array of algorithms, understanding basic concepts behind few common ones provide a solid foundation. Here we introduce two widely used algorithms conceptually, focusing on their intuition rather than mathematical details. Linear regression, supervised regression. Linear regression is used when goal is to predict a continuous numerical value like price, temperature, or score based on one or more inputs. It is the simplest form. Simple linear regression involves finding the best feature in straight line through a scatter plot of data points representing the relationship between single input variable, for example, outsiders, and the output variable, for example, out price. How it works. Intuition. Imagine plotting data point in a graph. Linear regression tries to draw a straight line defined by an intercept and a slope that comes closest to all the points. Closest is typically defined by minimizing the sum of the squared vertical distance, errors or residuals between each actual data point and the line predicted by the model. The resulting line represents the learned linear relationship, allowing prediction of the output variable for new input. Analogy. Think of drawing the best trend line through a scatter plot of height versus weight to predict someone's weight based on their height. Use cases. Predicting sales based on advertising spend, estimate crop yield based on rainfall, predicting exam scores based on study. Decision trees, supervised to track classification regression. Concept. The decision trees are versatile algorithms used for both classification, predicting categories, and regression, predicting numerical values. They work by creating a model that resembles a tree structure or flowchart. How it works in picture. The tree starts with a single root node representing the entire data set. The algorithm then recursively splits the data based on questions about the input features. For example, is color is equals to red? Is age lesser than 30? Each question corresponds to an internal node, and the possible answer lead down to different branches. The goal at each split is to create subsets of data that are as pure or homogeneous as possible. Regarding the outcome variable, this splitting process continues until certain criteria are met. For example, maximum tree depth reached, or nodes contained data points of only one class, resulting in leaf nodes that represent the final prediction or classification. Analogy and visuals. Consider a flowchart for deciding whether to play tests. Start with outlook, sunny, overcast, rain. If sunny, ask humidity, I or normal. If I, predict, don't play. If normal, predict, play. This sequence of questions form a decision tree. Use cases. Classifying emails as spam or not spam based on keywords, predicting whether a customer would click on an ad based on demographics, diagnosing medical conditions based on symptoms, deciding loan application approval. These examples illustrate how different algorithms approach learning from data. Linear regression learns a continuous linear relationship, while decision tree learns a set of explicit rules. The choice of algorithm depends on the nature of the problem, regression versus classification, the structure of the data, and desired model characteristics like interpretability. Decision trees are often considered more interpretable than some other complex models. Below are recommended resources for Module 4, articles, videos for further reading. In conclusion, machine learning, which is a subset of AI, enables systems to learn from data without explicit programming. Supervised learning uses labeled data for prediction, classification, and regression, while unsupervised learning uses unlabeled data for pattern discovery through clustering and association. Simple algorithms like linear regression and decision trees illustrate this concept. We've come to the end of the Module 4 of this data science course, where we looked into Introduction to Machine Learning under the following unit. What is machine learning? Unsupervised versus supervised learning, and common machine learning algorithms, linear regression, decision trees. We'll be diving into the next module, which involves career in data science. Thanks. You're going to be learning about variables in Python, right? In this particular video. A variable is basically just a container for storing data values. So you take your value like a number or a string, can assign it to a variable, then the variable will carry and contain whatever you put into it. So for example, let's go over right here. Sorry. Let's say x, which is going to be a variable is equal to. So we're going to assign our value to about. So x is a variable, we're going to assign our value to it. So let's say our value is 22. X is not equal to 22. So we don't have to write the number 22 in later script that we write. We can just say x, because x is equal to 22. It now contains that number. So we can hit enter, and we can say practice. We can open it, we can do a parenthesis, right? It's a print. Complete the parentheses. And then we say x. I'm gonna hit shift enter. Now it prints out the 22 because we're printing x, and x is equal to 20. This is our problem. And that's a variable. One really great thing about variable is that it assigns its own data. It's going to automatically do this. So we don't have to tell x that it's a integer. It just automatically knows that 22 is a number showing. We can check that by saying type and open parenthesis, type, open parenthesis, writer x. I will do shift enter again. Now it says x is an integer type, right? Now we only assigned an integer to x Now let's try assigning string value or some text to a variable. Let's say y is equal to main chocolate table. Sorry. Mint. Right. So we say mint chocolate chip. Now if we print that again, print open parenthesis y and do shift enter, it'll print mint chocolate chip. And if we look at the type, we can see that the type is okay. Let's see first. There's a type parenthesis. Right. We can see the type is a string this time and not an integer. Now again, we did not tell it that x was an integer and y was a string. It just automatically knew this. So let's go over here very quickly and have the rules in here because we're about to write a lot of different variables. I really learned in depth out these variables, right? The next thing to know about variables is that you can overwrite previous variables. Right now, we have main predictive, and that's assigned to variable y. So if I go down here and I say print y, and I hit shift enter, it's gonna print out mint chocolate chip. But if I go right above it, oh no, please, and say y is equal to, okay. If I print that out, okay, now it's gonna say chocolate, right? Now it's saying chocolate. Whereas up here, that's here, I'm reassigning it to y. It's still gonna say means chocolate. So I come right down here and I copy this and I paste it right here. If you're choosing the right one, perfect. Right here is gonna write y as in chocolate chips. So when we hit shift enter, gonna write chocolate chip. Variables are also case sensitive. So if you come up here and I say capital Y, let's see. There's a lowercase y, there's a capital Y. It's going to break up the correct one instead of mint chocolate chip. So I come here, I probably capital Y. It will give us the mint chocolate chip. Up to now, we only assigned one value to one variable, but we can actually assign multiple values to multiple variables. So let's do x, comma y, moment please. Comma y, comma z is equal to, assign multiple value to all of those. So we can say, chocolate, color. We can say vanilla, say for people, sorry. Vanilla, say comma, say work your road, work ye, world, only please. Working mode. Now let's gonna assign increment to X, vanilla to Y, working to Z. Ocean Gill is great. Sorry. Right. Sorry. Obviously. Okay, let me just type it. I wanted to copy and paste it, but better. It's not seeing it go through. Sorry. Okay, done. Right, brain. Right. So X, Y, Z. Remember, sorry, X, Y, Z. Yeah. Hit enter. It prints out chocolate, vanilla, and rocky road. These are all three different bags. You can also assign multiple variables to one value. And we can do this by saying X is equals to Y is equals to Z and is equals to whatever we like. So let's do is equal to root BF flow on place. Copy this. So let's fill in our X and Y and Z. Now they are all the exact same. So we looked only on looked at integer and strings, but you can assign things like list, dictionaries, tuples, and sets all to variables as well. So let's go right down here. Let's create our very first list. I'm gonna say it's underscore green a code. All eyes print is our variable. Remember, get it to an open bracket like this. An open bracket like this. Okay, maybe just this. And we get it for Premiere and copy all of those values. And we will stick it between amenities. That's like vanilla, rocky road. You don't want to hear it tag it. So we're gonna paste it within our list. Okay, so now within ice cream, we have three string value: chocolate, vanilla, and rocky road, all within the list. So all we could do is you could say X, comma Y, comma Z, start moments. It's equals to eyes underscore trait. These three values, chocolate, vanilla, rocky road, will be assigned to these three variables X, Y, and Z. And we can copy the string up here. Like up. Shift enter. Now there was a mistake. So remember this. Right. So let's click Shift enter again. So we now have chocolate, vanilla, rocky road. Now, something that we just do, which is really important, or something that you really need to consider, is how you name your variables. So right here, we have ice cream. Now, to me, it's exactly how we should write our variables. There are many different ways that you can write your variables. So let's take a look at that really quickly. Few more. There are a few best practices for naming variables. Firstly, what a lot of people would do, show you some good practices and some bad practices you should avoid doing. So the first thing we're going to look at is something called camel case. Let's say what a name it. Okay, let's name it camel. It's right. Test variable X. Moment. Okay, I'll remember more. Right. Now, if you have a test variable case, the commit case is going to look like this. We have the lower case test. We have the upper case variable case. Oh, x is equals to, sorry. This is what this variable is going to look like. And we can find it with a look for. Sorry. Swear. And this is what your camel case will look like into the lowercase, and all the rest of those are compound words, however you say. These letters are going to be capitalized and kind of separate where the words end at the beginning, like full right now here, and copy that. So the next one is called Pascal case. Now, Pascal case is going to look just a little bit different. Instead of the lowercase, our test is going to be in capital T in text. So test. Case. Now, this similar way of writing is very similar to camel case, but just the capital at the beginning. So let's look at the last. It's gonna be the snake case. Snake. It's around. Snake case. Now this is gonna be a bit different. The fact that you don't use any capital letters, you separate everything, use it or score. So we're gonna write text underscore. Remember underscore? Variable. I didn't realize that. Underscore. Yes. Let's change that. The variable. You must be sure you have a spelling fact. Now, typically, these are the best practices. These are what you typically want to keep, but probably the best one to use is the snake case right here. What a lot of people say is that it improves readability. And if you take a look at either of the camp case or Haskell case, which you will see people do, it's not as easy to distinguish exactly what it says. And the name of a variable is important because you can hear the condition format if people name them appropriately. So we do not be naming. So when naming the variable, you should write it as snake case because it's easier to read because each word is broken up by the underscore. So let's take a look at the variable names. These are all the words you can use. So test for. And to also view test underscore. We could also do please. Remember underscore test bar. You see that buffer that well people will start using it and with an underscore. They can do test var. Okay, please. Remember. You can do test bar capital P. Exactly. Capital P, capital C, capital V. Remember that in test bar. Or you can use something like test bar. Now adding a number to your variable, not be inherently a bad thing. Use it. Semi frowned upon, but there are definitely some use cases where you can use it. But one thing that you cannot do is do something like say put it to have a front here. Put it in front, it no longer works. That's the right? It no longer works. Syntax error. If on rough draft free at all, so let's take it out. So we can do that. It is an example of what you should not do. Like that's what we do that. Right. Also can use a dash. So something like voltage test dash a peep. That would work either. You also can use something like a space or a comma. Actually, any kind of symbol, a period or backlash, equal sign, none of those things will work within your variable. Now, another thing you can do within your variable is use the plus sign. So let's assign this x is equals to Woodway strength. It will say ice cream. And then we'll do a plus sign. What if you do it? You literally add these two strings together, right? That's what it's in. Add this string and this string together. So let's do string sheet. And now it now says ice cream is my favorite. What we cannot do in a variable, we cannot add a string and a number integer. So we can be ice cream is my favorite. If you try to do that, it will give us this error right here. Sorry, the error, right? So it's error. It says you can only concatenate, concatenate a string, not an integer, a string. So only a string plus a string for this example. You can also do a separate. X is equal to ice cream. If the y is equal to ice cream, no. Y is equal to 3 plus 2. No, sorry. Y is equal to 3 plus 2. Oh no, it says. Sorry. Now it was realized that you actually kept showing ice cream is my favorite. You know why? Because the X it's still reflective of here. And we have Y here. So we have to change this to Y. So let's bring shift enter. Now you can put the 5. You could also do an integer on an integer. Now, so far you've only included one variable in the printing statement, but you can actually add multiple variables within a print statement. So let's go right down here. So we need to have more. Okay. We're gonna say x is equals to x is equals to ice cream. Ice cream. What's that, please? Cream. We're gonna say y is equals to s. I would say d is equals to my favorite. My favorite. So look the bottom. We give it to the print x. A moment, please. Please. Okay. So come to the bottom and say print x plus y. That's equals to plus y plus z. Don't need enter that. Hit enter it. Well, we wrote that. We have ice cream is my first. Now we click add a space before my. I will aid shift enter. Can have ice cream in my favorite, so we can add space 2 in front of this. Okay, can have ice cream is my favorite. You can also do this exact same thing with numbers as well. Let's say x is equal to 1. Oh, number please. X is equal to 1. Y is equal to 2. Z is equal to 3. Our results equals 6. Now, one thing I'm trying to do was assign to one string a variable plus integer, and that did not work. But what you can do, you can do something like this. So X A Y is equals less. Let's get rid of the Z here. That's lost. I think it'll work. So let's try with that. So we can't concatenate tonight days. But we can do it in print statements is what we're doing presently is separated by our comma. Let me add this comma, it should work properly. There's an anchor. It has I squared 2. Again, this makes sense. Makes no sense. But yeah, I wrote now x, y, I squared 2. Doesn't make sense. Where are you able to combine a string and an integer separated by a const. This is the meat. The basics of variables, right? There's other things as well, but some of those things are quite advanced, which will be covered in this particular video, right? Now, these are the variables, or these are the basic things you need to know about variables. Thank you
for watching. If you found this video helpful and you're passionate about learning, don't forget to hit that subscribe button. We share practical tips, deep dives, and step-by-step guides to help you grow your knowledge and skills. You can also visit our website through the link below to access engaging courses. So if you're ready to keep learning and stay ahead, subscribe now and turn on the bell so you never miss a new video. See you in the next one.